Welcome to Spring LIB.
Okay, so we're in chapter 35, problem 3. So it says light of wavelength 580 nanometers falls in a slit that is 3.8 times 10 to the negative 3 millimeters wide. We want to estimate how far the brightest diffraction fringe is from the strong central maximum if the screen is a distance 10 meters away. Okay. So the angle to the first maximum is about halfway between the angles to the first and second minimum. So if we can look at equation 35(2), we can calculate the angular distance, and then we can just average these values to determine the approximate location. So the equation tells us that d sine theta m equals m lambda. So from this, we can see that theta m is the inverse sine of m lambda over d. So theta 1 then becomes the inverse sine of 580 times 10 to the negative 9 meters over our d, which was 3.8 times 10 to the negative 6 meters. And this becomes 8.678 degrees. And let's do the same thing for theta 2. So now we have inverse sine of 2 times 580 times 10 to the negative 9 meters over our d. And this equals now 17.774 degrees. Cool. So now we just take the average of these, theta average, and this is 13.23 degrees. So if this is our average or approximate angular location of the first maximum, we can now use trigonometry here and see that y over L is given as the tangent of theta. So from this we can see that y is L tan theta, or 10 meters times tan of 13.23. And we get a y of, y equals 2.35 meters. Cool.